The topic I am going to discuss in this video is about measures of transmissibility. In order to handle a disease in terms of control, prevention or eradication, it is very crucial to know transmission dynamics of that disease. In infectious disease epidemiology, we use some measures to study the transmissibility of a disease. Here we will discuss two measures of transmissibility: basic reproduction number and effective or net reproduction number. Basic reproduction number. It is the average number of successful transmissions by one infected individual in a totally susceptible population. Think about a hypothetical example for easy understanding. Suppose FMD outbreak has occurred in a totally susceptible cattle population. After 15 days of outbreak, 64 cattle get infected from 32 cattle. Therefore, basic reproduction number would be 64 divided by 32, that is 2.00, which implies that in an average, one FMD infected cattle could transmit the disease into two cattle. Basic reproduction number is denoted by R0. Interpretation of R0. Infection spreads when R0 is greater than 1. Infection remains constant while R0 is equal to 1, and infection will die out if R0 goes down less than 1. Moreover, R0 is also related to herd immunity threshold, that is HIT. HIT is the overall resistance of a population against a disease when a large proportion of its members are immune, and HIT is equal to 1 minus 1 by R0. So, from the R0 we can calculate herd immunity threshold. An example: considering the R0 of PPR in goat as 3, HIT is equal to 67, which implies that over 67% of goat population should be vaccinated to make them immune to gather herd immunity to prevent them from PPR. Now, effective or net reproduction number. It is the average number of successful transmissions by one infected individual in a population where proportion of susceptible is less than 100%. Effective or net reproduction number is denoted as Rn, and Rn is equal to proportion susceptible into R0. The basic difference between R0 and Rn is that R0 is calculated in a totally susceptible population, that is, proportion of susceptible is 100%. In contrast, Rn is calculated in a population where proportion of susceptible is less than 100%. Therefore, information of both basic reproduction number and net reproduction number is very important for strategic planning to prevent, control and eradicate diseases from the population. This is all about today's topic. Thank you very much.